Okay, let me explain on how to compute p-value using Microsoft Excel for one sample test. Okay, so first of all, what is one sample test? When we want to test whether the amount of water is exactly equal to 500, when we want to test whether BMI is more than 30, when we want to test whether customer satisfaction score is less than 4, this is what we call one sample test, where only one variable in one time. We compare all the variable with certain value only. We compare with 500, 30 and 4. So this is what we call one sample test. So after that, in step number 2, we collect the data. So in this case, we have 13 sample size. Okay, so the data in cm. So 49, 50, 45 until 48. So how to compute mean and standard deviation? Why we want to compute mean and standard deviation? Because we want to compute here test statistics. Okay, this is our aim, to compute the test statistic. Why? Because we can get a p-value from the test statistic. Okay, so p-value and test statistic is related to each other actually. Alright, but to get a test statistic, we must compute mean. So how to compute mean? Average B3 until B15. Okay, this is B3 until B15. And then we compute the standard deviation, STDEV.S. This is referred to sample standard deviation. Okay, the same thing from B3 until B15. So we get mean and standard deviation. Both are represent sample data. Sample mean, sample standard deviation. So this is the test value. In this case, I put 50 as a test value. Let's say when we look at to step number 1, okay, 500. So you put here supposed to be 500. If your data is represent amount of water, it will be 500 as your test value. And then to test whether BMI is more than 30, so you put here 30. Okay, so number 3, to test whether customer satisfaction score is less than 4, you put your test value 4. So test value is referred to your step number 1. Alright, where your mean and standard deviation is based on your step number 2, based on your data. Alright, so I made some editing. Okay, just now we put 50 here. Okay, so test statistic. What is test statistic? Test statistic is actually mean minus 50, 49.54 minus 50 divided by the standard error. Standard error is actually standard deviation divided by square root of n. Okay, so here is the formula. Okay, if you look at the formula. Okay, so this is a test statistic, a little bit small. Why is very small? Because this is 50. If you look at to this value, 50. Okay, I put the orange color, and this value mean very close to each other. When it very close to each other, so that's why your test statistic is very small. Let's say your test value is 55. You look at enter. Then automatically your test statistic is become larger. Okay, become larger. And then what is your p-value? Your p-value, if your test statistic is z-test, so the formula is norm.s distribution. Okay, so you put here equal normal. Okay, your s distribution is here. Where are you? Okay, and then you click on the test statistic, comma 0 means that you don't want the cumulative value. Okay, then you put it enter. Okay, so very small value. Okay, so change here to the number, you will get the value. Okay, see, very small number because you have the large test statistic. If let's say you change here again into 50, okay, so you get small test statistic and large p-value. See the relationship between mean and test value and test statistic and p-value. So they are what we call influence to each other. If you want the p-value to be small, you must have large test statistic. If you want to get large test statistic, your mean should be quite different compared to your test value. It should be differ to each other, not really close to each other. Okay, let's say test value is 60. See, your test statistic become 12 and your p-value really small. But this p-value is for two-tailed test. For two-tailed test. If you want one-tailed test, you take this value equal to this value and then divide by 2. So this is your p-value, one-tailed test. Okay, I change it, come back to 50. Okay. This is by using Z distribution. How about T distribution? Okay, look at here. Equal T distribution. You take this one. Alright. And then you click on test statistics. Okay, should be D3. D8, sorry, not B3, D8. And then comma, the degree of freedom is 13, right? 13 minus 1. That is the formula. 13 minus 1. And then comma 0 means that you don't want the cumulative value. And then you enter. Alright. Both value is almost equal value. Okay, it's almost the same. Normal distribution and T distribution is almost the same, but not exactly. But when you have a large, let's say here, I change to 50 minus 1. So it will be very close to each other, you see? Okay, so that's why when n tends to more than 30 and above, okay, when n become more 30 and above, so your Z test and T test will be almost equal to each other. So that's all from me, and then thank you.